The Big Bang theory is the leading scientific explanation for the origin of the universe. It posits that the universe began as an extremely hot, dense singularity approximately 13.8 billion years ago, and has been expanding ever since. This theory is supported by multiple lines of empirical evidence, including the cosmic microwave background radiation, the observed expansion of the universe, the abundance of light elements, and large-scale cosmic structures. In this document, we will explore these lines of evidence in detail and explain how they collectively support the Big Bang model. One of the earliest pieces of evidence for the Big Bang theory comes from the observation that the universe is expanding. In the 1920s, astronomer Edwin Hubble discovered that galaxies are moving away from us, and the farther a galaxy is, the faster it is receding. This relationship, known as Hubble's law, suggests that space itself is expanding. If we rewind time, the universe would have been smaller, denser, and hotter in the past, leading to the idea that it originated from a singular point. The discovery of the cosmic microwave background radiation in 1965 by Arno Penzias and Robert Wilson provided crucial confirmation of the Big Bang theory. The CMB is the residual heat from the early universe, which has cooled and stretched to microwave wavelengths as the universe expanded. This radiation is remarkably uniform across the sky, with slight variations that correspond to the initial density fluctuations that later gave rise to galaxies and large-scale structures. Another key piece of evidence is the observed abundance of light elements such as hydrogen, helium, and lithium. The Big Bang nucleosynthesis model predicts the precise proportions of these elements that should have been produced in the first few minutes after the Big Bang. Observations of the cosmic abundance of these elements match the predictions of the BBN model, providing strong support for the theory. The distribution of galaxies and cosmic structures also supports the Big Bang theory. Large-scale surveys have revealed a web-like structure of galaxy clusters and voids, which can be traced back to small density fluctuations in the early universe. These fluctuations, seen in the CMB, grew over billions of years due to gravitational interactions, forming the structures we observe today. Observations of distant galaxies provide a glimpse into the past, showing how galaxies have evolved over time. The further we look into space, the further back in time we see. Studies of early galaxies reveal that they were smaller and less developed than present-day galaxies, supporting the idea that the universe has evolved from a hot, dense state to its current form. The theory of cosmic inflation, an extension of the Big Bang model, predicts the existence of primordial gravitational waves, ripples in space-time caused by rapid expansion in the early universe. While direct detection remains challenging, indirect evidence from polarization patterns in the CMB suggests that inflation did occur, reinforcing the Big Bang framework. The Big Bang theory is supported by a wealth of observational evidence, including the expansion of the universe, the cosmic microwave background, the abundance of light elements, the large-scale structure of the universe, and the evolution of galaxies. Each of these pieces of evidence independently supports the theory, but together they form a coherent and compelling picture of the universe's origin and development. While research continues, the Big Bang remains the best scientific explanation for the beginning of our cosmos.